Can you please elaborate on the trade-offs between using data augmentation and collecting more realistic data for training for LLMs?
Yes, of course. Basically, the trade-off is using data augmentation and collecting more original data from training algorithm are basically very different in both perspective. Data augmentation basically involves artificially creating variations in existing data, which can be cost-effective and efficient. However, it might not capture the full diversity of real-world scenarios.
So, do you think LLMs themselves can be used to augment data?
Yes, exactly. So LLMs basically are very powerful models in that case and are very popular nowadays. So for example, you can take an existing sentence or paragraph and have LLM generate multiple paraphrased version, effectively creating new diverse data points. So this process enriching the data set with very with basically variation in wording, style, and structure.
Data augmentation in the context of LLMs. And today again, it will be described by Ms. Mehrun, who is going to give fair amount of details about data augmentation and how it is being used in the context of LLMs. So thank you very much, Ms. Mehrun. Over to you for this exciting lecture. Thank you.
Thank you so much. Assalamu alaikum, everyone. So in this presentation, I'll be talking about data augmentation. And in the previous lectures, you have learned about data pre-processing and data cleaning techniques in creating LLMs. So it's important to learn about some advanced methods that is usually included in every ML models nowadays. So one of them is data augmentation. So let's get started. So the prereqs of this topics are pretty basic. You should have a good understanding of training models on data sets. And the here's the outline of the presentation. So let's get started. Okay, so we all know the importance of data in LLM, and there is always a need of more data. The larger the data set is, the better. So in the world of these super smart language model, there always a hunger of more data, and it's like trying to learn more by reading more books. So sometimes there just isn't enough data to learn from. So that's where the data augmentation comes in, and it's like a magic spell that creates new examples from the ones that we already have. So this means the model can learn more, understanding and better and do cooler things with this variety of data it's been training on. So a very simple example is in the diagram a butterfly. So a butterfly is basically described in different varieties of filters. So this is exactly what data augmentation is. Now, you might wonder why we need data augmentation. So there are some challenges in the world of deep learning, and one of the biggest is data scarcity. And it's like having a hungry model that wants to learn, but there's just not enough food for it. So data augmentation is the remedy for this. It's like computing, conjuring up a magic fest from the limited data available. So it's not just about quality, like quantity, it's also about quality. So by creating these variation of existing data augmentation offer a bullet of learning opportunities. So this not only helps with the hunger of data, but also acts as a shield against overfitting. So overfitting is when a model memorizes data instead of learning from it. So it's like a student cramming for an exam, and the new instances generated through a data augmentation prevents model from becoming like memory expert, and encourages them to learn more robustly. Plus, this diverse diet of data helps model perform well on new unseen data sets, like a seasoned like chef mastering new recipes and different recipes at the same time. Now let's look at some techniques of data augmentation. First is data paraphrasing. So imagine you have a sentence like the sun is shining brightly. Now, let's say you want to say the same thing, but in a slightly different way. So you might rewrite it as the sun is gleaming brightly. So you have changed some word, but the overall meaning is still about the sun being very bright. So that's what text paraphrasing is all about. And rephrasing sentences while keeping the same message or context is what data augmentation is doing in this case. Then back translation. So this one is a bit language adventure, and you start with a sentence in one language, like English. Let's say you have the sentence, I like this book. Now you translate it into another language like Urdu, and it becomes like मुझे ये किताब पसंद है. Now here comes this interesting part. You take that Urdu sentence and translate it back to English. So what you get might not be exactly the same, but it will be something like, I adore this book. So, see what happened here. You just started with one sentence and ended up with a similar one, but you have introduced some variation in it. Next, we have masked language models. So, picture a sentence with some words balanced out, like the cat chased blank, like the cat chased the blank. So now you might know the missing word is mouse, but what if you want to teach a model to figure that out? So you just so mask some words like this: the cat chased the masked element. Now you ask the model to fill this blank. So it's like a word puzzle for models. So the model has to guess the missing word based on the context, like a detective solving a mystery. Another example is another technique basically is random insertion and deletion. So imagine you have a sentence like, she was reading a book in the park. Now let's add some randomness. We might insert an extra word like, she was reading a big book in the park. Or we might take a word out like, she was reading in the park. So it's like adding a surprise element in the sentence, and random insertion and deletion are ways to introduce a bit of chaos into the text. Then we have contextual augmentation. So this one is like completing a puzzle. You have a sentence and you want to add more sentences like that fit perfectly with it. For example, if you have if you have a sentence is, he walked into the bakery, and contextual augmentation might generate something like the smell of freshly baked bread filled the air. So it's like expanding a story based on what's already there. So the new text makes sense in the context of the original sentence, like adding more pieces to a puzzle, and until the picture is completely full and covered. So there are many other ways you can augment your data, and you really have to play with different techniques here to find the best one for your data set, because one technique cannot work for all of the data sets. Then so LLM, so in basically in LLMs, data augmentation plays a fundamental role in two different scenarios. First, when we are building LLM from scratch. So data augmentation enriches the training data, making the model more versatile. So techniques like text paraphrasing, back translation, and contextual augmentation come into play here. Second, during the fine-tuning process. Here, data augmentation is a critical technique. Imagine you have a pre-trained model, pre-trained LLM, and you want it to excel in a task like sentiment analysis. So this is where data augmentation steps in. To basically fine-tune the LLM, we need to expose it to task-specific data. And in the sentiment analysis, for instance, we employ a technique called masked language modeling. So this technique masks certain words in this text and requires the model to predict them. So it's like teaching the model to feel the sentiment hidden in the text. So talking about the implementation options that we have here, like you want to implement the data augmentation on your data set. So one way to do this is by using a Python framework called text attack. So it comes with an augmenter class that provides 6 different methods for data augmentation, and these all are different, and it can be many other ways as well. And there are many other manual and automatic ways to do it. You can write a Python script that will run on your whole data set. It's not a complex task when we implement it, but selecting and finding the best technique for your data set is more important. And also, we cannot forget uh, the most popular of 2023 generative models like LLMs. They can also perform this task very well and even better than any other thing. They can even create a data set that is very close to real world examples, and just by the use of their latent space. And raw featured data points of similar data, and then rearranging these points into all possible ways it can be rearranged to. So talking about that, there's some challenges that we might face during this data augmentation process. First is semantic integrity. It means that ensuring the new data we create during augmentation still carries the same meaning as the original data. We don't want to change the message behind it. And then computational cost. So this is about resources like computer power and time needed to create new data, and augmentation can be usually heavy on these resources, especially when dealing with a lot of data. Then biased amplification. If the original here's the thing that if you have a data set, data augmentation basically enhances that and show the points more clearly and more pronounced way. So if the original data set had any unfairness or partiality, so the augmentation can make it even more pronounced. It's like magnifying an existing problems. Then we have overfitting. So this happens when our model becomes too good at data, like it becomes too good at data it's trained on, but it struggles with the new and different data. So it's like studying one type of math problem so much that you become an expert in that, but then you find different math problems you can't solve because you are focused too narrowly on that one particular problem. So to wrap it up, our discussion about data augmentation is very crucial to recognize its important role not only in enhancing capabilities of LLMs but also in the broader landscape of machine learning and deep learning. So these concepts are not just theoretical; they have a practical application, especially when it comes to LLMs. Now we have to move forward in our presentation, and we will delve into building LLMs where we will explore how to construct these language powerhouses from scratch. So in the next lecture, we will be using all these techniques that we have studied in the previous lecture and this lecture as well to build an LLM from scratch. So that's all from data augmentation. If you have any question, you can ask now.
Thank you very much for this very great lecture. Uh, I have few questions that I wanted to ask. First of all, can you please elaborate on the trade-offs between using data augmentation and collecting more realistic data for training for LLMs?
Yes, of course. Basically, the trade-off is using data augmentation and collecting more original data from training algorithm are basically very different in both perspective. Data augmentation basically involves artificially creating variations in existing data, which can be cost-effective and efficient. However, it might not capture the full diversity of real-world scenarios. And on the other hand, collecting more original data provide a richer and more accurate representation of real world, but they can be expensive and very time consuming as well. So the key is finding the right balance. Data augmentation is great for fine tuning models, like improving their generalization on specific tasks, but it can't replace the need for original data, especially in cases where unique or rare situation need to be learned. And a thoughtful competition of both strategies can optimize LLM training and with leveraging their strengths of each approach.
Okay, one more question is, can you please also explain how data augmentation contributes to making LLMs more robust against adversarial attacks?
Basically, data augmentation plays a role in that too. So by introducing diverse variation in training data, data augmentation basically helps LLM become more resilient to subtle manipulation in the input text. So this is because during training, LLM encountered different phrasing and structures and styles, making them less sensitive to minor changes in the input. So when faced with adversarial attacks, where attacker try to manipulate input to deceive the model, LLM that have undergone extensive data augmentation are better at recognizing such attempts and maintaining their intended chain of thought. So, in a sense, data augmentation acts as a kind of a vaccine for LLMs, exposing them to a variety of scenarios and making them more immune to adversarial manipulations. So, that's how it basically contributes in that.
Also, do you think LLMs themselves can be used to augment data?
Yes, exactly. So LLMs basically are very powerful models in that case and are very popular nowadays. So for example, you can take an existing sentence or paragraph and have LLM generate multiple paraphrased version, effectively creating new diverse data points. So this process enriching the data set with basically variation in wording, style, and structure. So LLM can also generate additional example by answering questions, completing sentences, or providing explanations related to the existing data. So essentially, LLM act as a generative engines, creating new data, like new content that aligns with the existing data context. So this method not only enhances data, but also leverages the LLM model understanding and generation capabilities as well.
Okay, as you said that AI can generate data. Okay, so if an LLM is employed as generative model for data augmentation, particularly in this scenario where we have limited data, so do you have an example where this can be used?
Yes, let's say you have a small data set of customer reviews for a new product that you have, and you don't want to train a like you want to train a sentiment analysis model. So the original data is limited and making it challenging to capture the full range of sentiments. So here's where LLM shine as generative model for data augmentation specifically. So you can take each existing review and with the help of LLM generate multiple new reviews with varying sentiments. So for instance, if an original review says I love this product, the LLM can create augmentation like this product is fantastic or I'm not happy with this product. So by doing this systematically for each review, you expand your data with diverse sentiments and viewpoints. So LLM can also generate entirely new reviews based on product features and specifications or common customer concerns. And it basically further enrich your data set. So this approach is especially valuable when you have limited original data, as it leverages the LLM generative capabilities to create additional training examples, ultimately improving the performance of your sentiment analysis model.
Thank you very much for another fantastic lecture, Ms. Mehrunisa. And I'm also
Thank you
thankful
so
to all ladies and gentlemen for hearing this. And inshallah, see you all in the next lecture. Thank you.